Good day, everyone. I am Mr. Garth Reed, Student Ambassador at the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. Today, we'll be looking at a 2016 past paper question on vectors for the CSEC Additional Mathematics. All right, so we're focusing on vectors. Now, the question says that the position vector of 2 points A and B relative to a fixed origin O are vector A and vector B respectively, where vector A is equal to 1, 2, and vector B is equal to negative 3, 5. And it says that the point P lies on the vector AB such that vector PB is equal to 1 over 4 multiplied by the vector AB, and we are to find the coordinates of vector OP. Okay, so let's go right into the solution here now. All right, so we know that vector A, all right, which is the same as vector OA, all right, that's a position vector, is equal to 1, 2, all right, and we know that vector B, which is the same as vector OB, is equal to negative 3, 5. All right, that is what we're given. And the question stated that the vector PB is equal to 1 over 4 multiplied by the vector AB. Okay, that is what it says. Good. Now, please note here, I'm going to put it in blue for you. So note that the vector AB, all right, so we're starting at A, ending at B. A is called the initial point or the starting point, and B is called the terminal point or the ending point. And that is equal to the vector AO, all right, plus the vector OB. We can also write it as OB, right, the vector OB minus the vector OA, all right, because if I'm going from O to A, all right, and then I'm saying that I want negative OA, right? Negative OA and OA are just opposite vectors, right? So that is the vector AB. Also, we can say vector PB is equal to the vector PO, all right, plus the vector OB. We can also write it as the vector OB minus the vector OP. Okay, so those are saying the same thing. Good. So I'm going to use the second one. All right, I'll be using the second one here and the other one here. Those are the two that I'll be using for this question. But you can use any one of them. Okay, so let's do that. So vector PB is equal to vector OB minus the vector OP. And that is equal to 1 over 4 multiplied by the vector AB, which we know is vector OB minus vector OA. All right, minus the vector OA. That is what we have. So that is what we have. Just now simplify further, all right, plugging some information that we know. So we were given that the vector OB is negative 3, 5, and we were given that the vector OA is 1, 2. All right, that's 1 over 4 multiplied by. Now let us subtract these two vectors now. That's negative 3 minus 1, which is a negative 4, 5 minus 2, which is 3. All right, and on the left-hand side, we have the vector OB, minus the vector OP. Good. So that is what we have there. So remember now that the question said that we are to find the coordinates of vector OP. Let us now transpose this equation here for OP. All right, so if you rearrange the equation to find OP, you will get the vector OP is equal to the vector OB minus 1 over 4 multiplied by the vector negative 4, 3. All right, so what I did was just transpose the OP, all right, the vector OP. So if I put the vector OP here to the right-hand side, it will turn up positive, right? And I can carry this 1 over 4 multiplied by this vector on the left-hand side. I will get vector OB minus a quarter times that vector, all right? So that is what I have. Good. So let's now continue. We know what is the vector OB, right? So we can say that the vector OP is equal to the vector OB, which is negative 3, 5, minus 1 over 4 multiplied by the vector negative 4, 3. That is what we have, right? So we now have negative 3, 5. I'm going to perform scalar multiplication here. So I'm going to multiply the 1 over 4 by each term here in the matrix or the vector, right? So 1 over 4 multiplied by negative 4, that's going to give us a negative 1. And 1 over 4 multiplied by 3 will give us a 3 over 4. All right, that is what we will get. So let us now subtract these two vectors here. So we can now say that vector OP is equal to, that is going to be negative 3 minus a negative 1, right? Which will give us a negative 2, and 5 minus 3 divided by 4, which is 17 divided by 4. All right, so that is going to be our vector OP. Good. Now remember, we need to state the vector OP as coordinates. All right, so we can say, therefore, the vector OP, all right, the vector OP is equal to x, y, all right, which is going to be equal to negative 2, all right, so that's going to be equal to negative 2, comma, 17 over 4, all right? And that is my solution to this past paper question on the 2016 paper, okay? So if this video was helpful for you, please ensure to like this video, subscribe to the channel, and also share this video with your friends. I am Mr. Garth Reed, Student Ambassador at the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. I thank you for joining.